Alright, I apologize. The previous video was cut. This example was supposed to be included in the Vant Hoff factor part, but there seemed to be a problem with the audio, so I made a separate video. So now let's try answering this one. What is the normal boiling point of the following solution? 21.2 grams sodium chloride in 135 grams of water. So normal boiling point, so we're still talking about colligative properties. So you're going to use the formula for the boiling point elevation. Pero may Van 't Hoff factor na. So why did we include the Van 't Hoff factor? Because our solute here is an electrolyte. And since this is an electrolyte, we have to include the Van 't Hoff factor. So what is the Van 't Hoff factor for sodium chloride? It's 2. Why? Because when you dissolve this in water, because it's dissolved in water, sodium becomes sodium plus and chlorine becomes chloride negative. So you produce 2 ions in the solution. So now, we are looking for the boiling point of the solution. So expand this term. This becomes TB minus TB naught is equal to I kBm. So the TB naught, you are expected to actually know the TB naught, lalo na at tubig yung pinag-uusapan natin. So the boiling point of your pure solvent, which in this case is water, it's 100 degrees Celsius. And the Kb, or the ebullioscopic constant, you should also be familiar with this kasi nga, water is the universal constant. So 0.52 degrees Celsius per molar. Degrees Celsius per molal. Now, you are looking for this term, boiling point of the solution. Ito yun. Now, the M, or the molality, we still don't have a value for that, so you need to solve for that. And the formula is this, moles of solute over kilograms of solvent. So for the kilogram of solvent, madali na lang yan, just convert this to grams. How do you do that? You divide it by 1,000. So this becomes 0.135 kilograms. Ayan. Paano yung ating moles ng solute? Meron kang 21.2 grams. So 21.2 grams, convert that to mole. So 21.2 grams ng sodium chloride converted to mole. What's the conversion factor? 1 mole of sodium chloride is equal to how many grams of sodium chloride? Get your periodic table, get the atomic weight for sodium and chlorine, then get the total. So this is 23 plus 35.45. This is 58.45 grams. So sa baba, 58.45 grams para mag-cancel. Tapos 1 mole ng sodium chloride. So cancel. Now 21.2 divided by 58.45, that is 0.363. So 0.363 mole. Now you can solve for the molality. It's kind of, it feels like a tongue twister, no, when you say molarity and molality. So sometimes, ayun, nabubulol ako when I say it. So 0.363 divided by 0.135, this is now 2.69. So the molality is 2.69 molal. So you have now all the terms, and the Van 't Hoff factor is 2. Now substitute lang. So TB, ito yung hinahanap natin, let it be that way, minus 100 degrees Celsius is equal to, what's next? I, 2, Kb, 0.52 degrees Celsius per molal times 2.69 molal. So, molal cancels. Now, simplify this term, no? Input mo na sa calculator. 2 times 0.52 times 2.69. This is equal to 2.798. Ayan, what's the unit? Degrees Celsius. Okay, so TB minus 100 degrees Celsius. How do you isolate TB? You transpose 100 degrees Celsius to the right-hand side of the equation. So TB is now equal to 2.798 degrees Celsius plus 100 degrees Celsius. So if you add 100 to that, you have 102.79 degrees Celsius. So this is the boiling point of the solution, no? 798. And you can simplify it as 102.80 degrees Celsius. Okay. So now, we follow the concept. This is actually correct because if you add, if pure water is 100 degrees Celsius at nag-add ka ng solute, in this case, it's sodium chloride, tataas talaga yung boiling point ng solution. Mas mataas siya kaysa dun sa boiling point ng pure. So, we'll have a separate video, no, wherein we practice on problems on colligative properties. So, that's it for this lecture. Thank you.